Okay,
Oh,
yes. So we were talking about the Celsius and the Kelvin one. So basically, if there is a temperature at which the movement of the particles are almost or actually freezes, so that is known as the absolute zero temperature, and that absolute zero is for Kelvin, right? On the Kelvin scale, this zero is absolute zero, because we use the term absolute when you are completely sure about the position of any body. So basically absolute zero means that at this specific temperature the motion of the particles are completely freeze and they are no longer moving in any direction, right? So that's why we are taking the reference of absolute zero. Okay,
yeah.
and further if we just mark the value on the graph, so you can easily mark on, let's suppose if this scale is given in degree Celsius, so you have to mark at minus 273. Let's suppose this is the point which shows you minus 273. So at this point, if we compare with the Kelvin scale, so Kelvin will be 0, but your Celsius will be minus 273. Okay, so this will be the graphical representation that if you start moving from the increasing temperature to the lower temperature, so your graph will move like on the negative side of the graph, and on negative 273 degrees Celsius, your answer will be equals to 0 Kelvin, that is known as absolute zero. Okay. And at this temperature, the net moment of the particle will equals to be zero. Okay.
All right, sir.
So this is the concept of absolute temperature, and previously we already discussed about the concept of increasing temperature. So we know that increasing the temperature will also increase the kinetic energy of the molecules. And further, if we talk about some more concepts, so let's suppose if we consider the gas molecules in the sense if we are having a cube shape over here or any container, right? So if we consider a 3D shape in which gas molecules are trapped, and if we consider a single gas molecule, so you know that this gas molecule will move in any direction randomly with high speed. So let's suppose it collide at this point and then reflect back or in downward direction or in any random direction, right? So basically when this molecule collides with the wall, so when molecule collides with the wall, so basically this molecule applies some force on the wall, right? Because it is moving randomly, so it will collide with the wall of the container in any direction with any angle. The molecule actually collides with the wall of container. So actually it collides with the wall of container because of random motion, and also it collides with other molecules, right? Not with the wall of container. It will also collides with other molecules too. Okay, so there are two possibility for a single molecule, that either it collide with the other molecule, or other option is that it will collide with the wall of the container. And if you remember the concept of the pressure, right? So basically, if you apply force on a certain given area, so when you apply force at any specific area, so force per unit area gives you the concept of pressure, right? So when the molecule collides with the surface of the wall, so it collides with some specific area on the wall. So if you take the ratio of that force and that specific area of the wall, so you will get the pressure of the gas molecules. Okay, so we can say that when molecule collides with the wall, it exerts on a specific area, and that concept is known as the pressure of the molecules, right? So this will be the pressure of the gas molecules force acting per unit area. Okay.
Okay.
And further, if you consider any specific direction, like if we consider this position, so you can see at certain area, the force is applied by the molecule, and on the other side you can see that there is also a certain area on which the force is applied by the molecule. So this is the concept of the pressure that we are talking about, that if you increase the temperature, if you decrease the temperature, so how the pressure and the volume of the gas actually changes, right? And there is one more particular theory, you can say that, or concept related to the motion of the molecules or the particles, that is known as the Brownian motion. Any idea about the Brownian motion? If you already studied that concept?
No, sir. No, sir.
Okay.
Basically, it's like, can I
Hmm.
try?
Okay.
It's like, for example, let's take the example of air. So
Hmm.
if I were to release, let's say, perfume or something,
Hmm.
perfume would be dispersed around the room because of diffusion, but then it also gets dispersed because it's being bombarded by particles in the air. So
Okay.
Brownian motion is the
Hmm.
random movement or zigzag
Yes.
motion of particles
Yes.
due to bombardment of particles in a fluid.
Yes. So basically, the main concept, yes, I also got the answer in the chat. So both of you answer in the sense that it is basically the random motion of the particle, right? So the basic main idea in this Brownian motion is about the random motion of the particles, right? When you observe them in the microscopic manner, like, because particles are not observable by the normal eye, so we have to observe the particles with the help of the microscope. So if we start with the concept of the Brownian motion, so we know that all matter is made up of tiny particles, right? So we already know about this. And to observe that the tiny particles, so basically we are talking about the matter, and matter is made up of tiny particles. So basically, Robert Brown is the name of the scientist that actually described the random motion of the pollen grains in water. So actually, the experiment was performed with the help of the pollen grain in water. So basically, Robert Brown performed the experiment that he put some pollen grain in water, and when he observed the motion of the pollen grain in water with the help of the microscope, so he observed that particles are in random motion and they have their constant and random motion. So actually, that gives the concept of the Brownian motion, because Robert Brown is the name of the scientist, so that's why the name of this concept actually renamed as Brownian motion. So we can say that the Brownian motion is the random motion. So the random movement of particles in a liquid or a gas, because solids are not able to move freely. By large number of collisions with the smaller particles, right? So this is the concept of the Brownian motion, right? Or
Yes,
if
sir.
you consider any small particle, just like the pollen grain or the smoke particles that are suspended in a liquid or a gas, and if you observe the motion of that particle with the help of the microscope, so you observe the random motion like this. If we consider any specific, so in any specific container, if we consider the movement, so that will be random in any direction. So this shows you that particles are moving in any random direction, right? Any other idea about the Brownian motion? Anything that you want to add? So basically, when we are talking about the Brownian motion, so there is a concept of the random motion, and we observe that if we consider the microscope and we observe the motion of the pollen grain of the small particle in liquid or gases, so you observe that they are moving in the random direction, and that is the concept of the Brownian motion, right? So basically, first chapter is like almost the basic properties of the particles, basic properties of solid, liquid, and gases, right? You can see that we discuss many concepts, and most of concepts you already know about that. So that is not much very difficult. And let's suppose if we consider some questions related to the first chapter, so that will also give you idea that how much content that you covered from this first chapter. Okay, so the MCQs that was not included in work energy power, that is related to the journal physics section, actually included over here with the energy section. So basically we are talking about transfer of thermal temperature, thermal properties, kinetic model. So this is kinetic model of matter, and it contains a mixed type content because all things are related to the thermal process. So sometimes you got the question that is combined from the other concept. So in the first question, a gas in a container of fixed volume is heated. What happens to the molecule of the gas? So there is a fixed volume and gas is actually heated. So what happens to the
C.
molecule of the gas? Uh,
C.
C, they move faster. Okay. C, they move faster because they collide less frequently. It is not possible because it actually happens when temperature decreases. They expand, they are not able to expand because they have fixed volume. So they move faster, right? And they move further apart. That is
Yeah.
also not possible because again the volume is fixed, so they are not able to move far away from each other. Okay, we will discuss question 2 later because that is related to different concept, the density of molecules. But still, you are able to answer this one if we consider this question. And one more thing, if you observe in your daily life, so you always observe that the AC or the freezing part in the refrigerator are always on the top, right? Okay, D answer. And if we consider the heater, so we always place the heater on the ground surface.
Yeah, it's D.
Okay. So, what is the logic that why we always fit the AC on the maximum height and heater we placed on the ground level? So, what is the logic?
Because hot air rises up because the density becomes lesser, and then we put the refrigerator on top,
Hmm.
or the freezer, sorry, the freezer on top because cold air
Yes,
falls down as
yes,
its density is greater.
for a current.
Because volume is inversely proportional, and cold substances have lower volume, so a
Yes,
higher density. Hotter substances have a higher volume and a lower density.
yes. So, I also got answer in the chat. So, basically, you are saying, right, that if we consider the cold temperature or low temperature, so in low temperature, your density of the molecules will be high because in cooling the molecules are coming very close to each other. So high density means that your molecules or the flow will be in downward direction. So that's why the cooling part will always on the top. And if we consider the hot temperature or the hot body, so that is actually placed on the ground surface because you know that in hot temperature the molecules are far away from each other and the density will decrease. So less dense molecules will always move in the upward direction, right? Just like the less dense material will float on the water and the dense material will sink into the water. So same situation. And in this question, you answer option D. When the refrigerator is first switched on, what happens to the air near the cooling unit? So move closer together, the density of this air increases, right? And in question 3, there are different arrangement of the molecules in a solid as the substance melts. So when substance melt,
A.
okay, option A, option A. Because when substance starts to melt, so actually it converts into the liquid. So they are not very far away from each other. They will not move very far. So A is the right choice because we have to consider solid to liquid state. So in liquid still molecules are close together, not very far away. Question 4. Some gas is trapped in a closed container. The gas is cooled and the volume of the container is kept constant. So volume is constant and gas is cooled actually. So what happens to the gas molecule? Option D, they move more slowly. Okay. So basically when you cool down the gas and the volume of the gas remains constant. So basically there are two possibilities from the question. One is like C, they get close together, and the second
Yeah, it's
option,
either C or D.
they move very slowly. So what you
D.
suggest?
I'll go with D.
Okay,
D.
so D will be the right choice.
Because volume changes when you change the state.
Yes, because we are talking about the temperature, so gas molecules
Yeah.
cool down, so your kinetic energy actually decreases. So basically, they move more slowly, right? And in a liquid, some energetic molecules break free from the surface even when the liquid is too cold for bubbles to form. So what is the name of this process? Okay, one answer I got is D. We also discuss these process because there is a clear difference of evaporation and the boiling in our syllabus.
Yeah, it's D. It says from the surface.
Yes. So some energetic molecules break free from the surface. So that is evaporation process, because that is normal process you already know about and you already studied. But still we studied that concept in our syllabus in the next chapter. And a gas is in a sealed container of constant volume. Again, we are having constant volume. Sealed container, the gas is heated and the pressure of the gas on the walls of the container increases. Okay, one answer I got is C. Okay, how do the particles of the gas cause this increase in pressure? So one answer I got is they hit the container more frequently. So basically, we discussed the section where it is. Yes, we are talking about this gas molecules. So same concept we have to apply on this question, that when we consider the motion or the collision of the molecules on the container or the wall of the container, so that gives you the concept that there will be high pressure. So if they hit the container more frequently, so that gives you the concept of increase in pressure, right? Because if they hit each other, so we are not able to measure the pressure, because molecules are very tiny one, so we are only able to find out the pressure with the reference of
C.
the container.
Yeah, with the container, sorry.
Yes. Question 7.
A.
Okay, A. Okay, so basically, in this process, they are asking some of the liquid in a dish evaporates as shown. So which molecule leave the liquid and which molecule in the liquid have greater average kinetic energy? So molecule that leave have high energy, right? And molecules in the liquid have greater average kinetic energy before evaporation. Yes, so A is the right option. So you can see questions are very much difficult, mostly are to the gas very close to each other, away from each other. Okay, so this is related to heat capacity. We will discuss in this concept in next chapter. Okay, so basically you got the concept from the first chapter of thermal physics that is related to the basic kinetic property of the molecules. So there is nothing new in this chapter that you heard for the first time. Almost you have all the concept that you already studied or you already heard about that at such subject. In the second chapter of the thermal physics, we have to study some quantities like specific heat, the difference between evaporation and the boiling, latent heat, and there is a concept of thermometer previously, but that was excluded in the last syllabus change. So now we don't need to study about the thermometers. That is also excluded, right? Otherwise you find
Yeah.
many questions related to the thermometer in your past papers, because there is a complete comparison that why we use water, why we use mercury in thermometer, but that topic is excluded, so you don't need to solve that question from your past papers also. So now this section is also shrink out because of many topics excluded from this section. So this is the short section, and we will inshallah complete this section in 1 or 2 week very easily. Then we start to solve some more past papers questions, right?
Yes, sir.
Till then practice the question from any section that you want, and I will also give you the schedule of your test for this week, right?
Okay.
Alright.